Algebra 2 Lesson 1-4, Solving Equations. An equation is a statement where two expressions are equal. The solution of an equation is finding all the values of the variable that make the equation true. Inverse operations are operations that undo each other. For example, multiplication undoes division, addition undoes subtraction. An identity is an equation that is true for every value of the variable. And a literal equation is an equation that uses at least two different letters as variables. And normally we consider these to be like formulas, because there's normally more than one variable. All right, properties of equality. Many of these are reviewed. Some of them might be new. Nothing big. Just be aware of them. Assume A, B, and C represent real numbers. The reflexive property says that A equals A. In other words, 5 equals 5. That's true. It's going to be true. It's reflexive. In geometry, that's when we said like side PS was equal to side PS because it was the same side. It's also referred to sometimes as called reflexive conjecture as well. Okay. Symmetric property says if A equals B, then obviously B has to equal A. If 1/5 equals that's just 1/2 equals 0.5, then 0.5 equals 1/2. Okay. If 1/2 equals 0.5, then 0.5 has to equal 1/2. The transitive property says if A equals B and B equals C, then A has to equal C. If 2.5 equals 2.5 and 2.5 equals 5 halves, then 2.5 has to also equal 5 halves. The substitution property says if A equals B, then you can replace A with B and vice versa. If A equals B and 9 plus A equals 15, then 9 plus B also has to equal 15. The addition property says if A equals B, then A plus C equals B plus C. If X is 12, then X plus 3 equals 12 plus 3. Okay, subtraction property says if A equals B, then A minus C equals B minus C. Okay, if X is 12, X minus 3 equals 12 minus 3. Multiplication, if A equals B, then A times C equals B times C. For example, if X equals 12, then X times 3 equals 12 times 3. And the division property says if A equals B, then A divided by C equals B divided by C, provided C does not equal 0, because division by 0 is undefined. So if X equals 12, then X divided by 3 equals 12 by 3. All of these are review. You may not have seen these written in this exact form before. You should be familiar with them. If you have to memorize them, no, because you probably already know them better than you think you do. All right, solving a one-step equation. Basically, isolate your variable and solve. Use inverse operations. Please show your work, even the easy ones, because eventually they'll become harder and you'll need to show your work. So x minus 8 equals negative 10. To get x by itself, we have to do the opposite. They subtract 8, so we'll add it. Adding 8 to both sides, that cancels out. X equals negative 10 plus 8, which is negative 2. And of course, you can always check these. Negative 2 minus 8 does indeed equal negative 10, so it does check. Letter B, 8.5 equals 5p. To get p by itself, they multiplied p by 5, so we will divide by 5. If you take 8.5 divided by 5, and I'm actually going to do that over here just to prove you don't need to use a calculator all the time. That's going time. And it's going 7, so p equals 1.7. Okay, simply done, fast and effective. Solving a multi-step equation, which means more than one step. Sometimes that means you have to collect all the like terms on one side of the equation. Distribute if the distributive property is necessary. Isolate your variables and solve. So if we look at letter A here, the first thing we have to do is to get x by itself. The first thing we have to do is get rid of any of the parentheses by using the distributive property. So if I distribute here, I will get 6x minus 3. Distribute here, make sure you take that negative all the way through. Negative 6x minus 8 equals 11x. Now I can simplify like terms. And looking at the left side of the equation, I do notice that both my x's cancel out. 6x and negative 6x is nothing. Negative 8 and negative 3 is negative 11. So I have a negative 11 equals 11x. Divide by 11. X equals negative 1. And I'm done. Always make sure you box your your final answer so that I know you are completely done with the problems. Letter B here, there's nothing to distribute, but I can simplify. So let's remember, the equation is divided by the equal sign, so left-hand side versus right-hand side. On the left-hand side, I have a 5w and a negative 12w. So negative 12 plus 5, okay, is negative 7w. Okay, so I have negative 7w plus 8 equals 16 minus 15w. Now I need to get all my variables on the same side. I'm going to get them to the left side so that I like it there. So I'm going to add 15 here. I'm going to subtract 8 here. This will cancel, that will cancel. Negative 7w plus 15w is 8w. And 16 minus 8 is 8. So divide by 8. W equals 1. Very simple equation to solve. Okay, fairly simple and straightforward. Okay. They won't always be quite that easy, but they start off pretty easy. Using an equation to solve a problem. Okay. Word problems, in other words, always known as real-world problems. Two brothers are saving money to buy tickets to a concert. Their combined savings is $55. One brother has $15 more than the other. How much has each saved? And you're going to go, I can do this in my head faster. Why should I have to write an equation? Because I told you to. And it's because it's necessary. If you can do it with the easy ones, then when they become harder, it'll be easier to apply them. So let's take a look at this. I'm going to define variables first. Okay, so two brothers are saving money. Their combined is 55. One brother has $15 more than the other. So I'm going to let x equal brother number 1. And obviously x plus 15, because he has $15 more, is brother 2. Okay. Together, they have $55. So brother 1 plus brother 2 have to have $55. So there's your equation. Because it's going to ask you to write an equation. Now that we've had our equation, we can solve it. X plus x is 2x, and we have 2x plus 15 equals 55. Subtract 15. 2x equals 40 divided by 2. X equals 20. So brother 1 has $20. Okay. So one brother has $20, and the other brother has $15 more than that. So x plus 15 will be 35. So since this is a word problem, we must write it in a complete sentence. Okay, so one brother has $20. The other has 35. There's our equation. We defined our variables, we wrote our equation, we solved our equation, we answered it in a complete sentence, as you should. All right, consecutive number problems. This is a good review. Remember, if they're consecutive numbers, it means they come in a row. 4, 5, 6, 12, 13, 14. If they're consecutive odd numbers, 7, 9, 11, okay, you'll notice there's two numbers between them. If they're consecutive even numbers, 14, 16, 18, still two numbers between them. So remember, consecutive numbers, x, x plus 1, x plus 2. Consecutive odd numbers, x, x plus 2, x plus 4. Consecutive even numbers are also x, x plus 2, x plus 4. Again, this is review, things you should already know. So, three consecutive numbers that have a sum of 126. So I will let x equal my first, x plus 1 equals my second, x plus 2 equals my third, because I need three numbers, so I know I need three variables. Sum means add them together. X plus 1 plus x plus 2 has to equal 126. So now we'll add them. 1, 2, 3 x's. 3x plus 1 plus 2 is 3 equals 126. Subtract 3 from both sides of the equation. You now have 3x equals 123. Divide by 3. X equals 41. So our numbers would be 41, add 1 to that, we have 42. So here we have 41. 41 plus 1 equals 42, and 41 plus 2 equals 43. So the three numbers are 41, 42, and 43. And those are your three consecutive positive number. And you should add them together to make sure they truly do equal 126. Moving on. Sometimes no value of the variable will make an equation true. For identities, all values of the variable will make the equation true. So let's take a look at some equations which you'll have either no solution or infinitely many solutions. It says, is the equation sometimes, always, or never true? Let's take a look at this. 1 plus 5x minus 6 equals 6x minus 5 minus x. So let's solve it. And that's the only way you can figure these out is you have to solve the equation. All right, here 1 minus 6 is negative 5 plus 5x equals 6 minus x is 5x minus 5. If I was to solve this equation, I'll add 5 here, add 5 here, and that will give me 5x equals 5x. That's a true statement. 5x does equal 5x because when I solve this, I'm going to get 0 is equal to 0. Okay? Since this is a true statement, and it's always going to be a true statement, and if I subtract 5x from this side and I subtract 5x from this side, I'm going to get 0 equals 0, which is always true. Okay? Which means this is an identity. Right? It's an identity equation because any number I put in for x is going to work. No matter what number I put in for x, I'll get a true equation every single time. So it has infinitely many solutions, so it is what we call an identity. And identities are always true. Let's look at letter B here. Negative x plus 2 parentheses 5x minus 1 equals 2 parentheses 3x plus 4 plus x. Again, let's simplify. So I have negative x plus 10x minus 2 equals 6x plus 8 plus x. All I did was distribute. That's the first thing I did. Now I will combine my terms. Negative x plus 10x is 9x. Minus 2 equals 6x, and x is 7x plus 8. So I'm going to subtract 7x from both sides. I'll add 2 to both sides. And I will get 2x equals 10, so x will equal 5. X equals 5 is true for this equation, but it may not be true for all equations, which means this is sometimes true. If you get an equation that has an answer, that means it's sometimes true. It only works sometimes. In this case, this will come out to be true every time you substitute 5 for x. If I substitute in something other than 5, it will be a false statement. If you get a false statement, like for example, maybe I would have gotten that 4 equals 12. 4 never equals 12. And since 4 never equals 12, it would be never true, and there would be no solution. So this has a solution, and that makes it sometimes true. Now let's solve a literal equation. Okay? You can solve a literal equation for any one of its variables by using the properties of equality. You solve for a variable in terms of another variable, which means you've got to learn how to read these. The hardest thing for a lot of people is to understand what in the world am I solving for. For example, c equals 5/9 parentheses f minus 32. We're going to find f in terms of c. So in other words, we're solving it for f. If it says find f, that means we're solving it for f. But we're solving it in terms of c because the c is not going to go away. For those of you who don't know, this is the Celsius to Fahrenheit, Fahrenheit to Celsius conversion factor. So if I have this equation, I'm just going to rewrite the equation so I can play around with it. If I want to solve this for f, I have to get f by itself. The easiest way to do that, I can either distribute the 5/9, which clearly is going to get very, very ugly because of the fraction. Or I can do it's 5/9 is multiplied by the entire parenthesis f minus 32. So what I can do is do the inverse operation of that, and I can multiply it by 9/5. If I multiply this by 9/5, I have to do the same thing for the other side, multiply it by 9/5. This will cancel with this. I now have 9/5 c equals f minus 32. To solve for f, I just simply need to add 32. Since there are not like terms, I'm just going to rewrite this as 9/5 c plus 32 equals f. And I have now solved this in terms of f. I found f in terms of c because c is still in my equation. Now there are different ways to do this. I could have distributed it and solved it another way, but this is probably the easiest way to solve it. Let's look at letter B. K equals C plus 273. Find C in terms of K. In other words, isolate C by itself. Okay, we're going to find C. In other words, solve for C. Okay, so if I have K equals C plus 273, this is a very simple equation. Subtract 273. These are not like terms, so we can't combine them in any way, shape, or form. So K minus 273 equals C. I have solved. I found C in terms of K. Last question. K equals 1,000, parentheses 1 plus 0.05 T. Find T in terms of A. So in other words, we have to isolate T. And there's two ways I can do this. And I'm actually going to show both ways so that you can be familiar with this. The easiest way is I look at this and I go, let's just distribute it through. Let's just, remember, in letter A, we did not distribute the 5/9 because it was going to make an ugly fraction with the 32. I could have, but I chose not to because it was easier not to. Here, I'm going to distribute it, so I'm going to have A equals 1,000 times 1 is 1,000, plus 1,000 times 0.05 is going to be 50. T. Now I need to solve for T. So the first thing I'm going to do is subtract 1,000. Okay. So I have A minus 1,000 equals 50T. To solve for T, divide by 50. So T equals A minus 1,000 divided by 50. That is one way to solve this equation. Now some people would have looked at me and said, can't you just do what you did before, which was divide by 1,000? Okay, like we multiplied by the reciprocal over there. Yes, you can. Let's take a look at this. Same problem. A equals 1,000, parentheses, 1 plus 0.05 T. So I can take this side and divide it by 1,000. Take this side and divide it by 1,000. So I now have A over 1,000 equals 1 plus 0.05 T. So now we have to subtract 1. So I'm going to have A divided by 1,000 minus 1 equals 0.05 T. Here's where it gets a little hairy. Okay, this is why this form of the question is a little bit harder. Now I'm going to divide by 0.05. Or in other words, okay, multiply by 1 over 0.05. It's the same thing. I'm just going to, if I divide by 0.05, okay, that's the same thing as multiply by 1 over 0.05. So I'm going to take this entire thing here and I'm going to multiply by 1 over 0.05. Okay. So the A stays on the top. If I take 1,000 and multiply by 0.05, I'm going to get 50 minus 1 divided by 0.05. Now here's the fun part. You can't have a decimal within a fraction. So I cannot leave this as 1 divided by 0.05. So I have to multiply everything by 100. Okay, to get rid of the, I have to multiply this by 100. So I'm going to have A over 50. Okay, that's an A. Let's try that again. A over 50 equals 100 divided by, minus, not equals. It'll happen in signs. Okay, equals T. You might be looking at me going, but that's nothing like the other question we had over there. Okay, well, we could actually simplify this a little bit more. Because if I do that, okay, what's 100 divided by 5? It's 20. A divided by 50 minus 20 equals T. And I'm finally done with it at that point in time. Yes, if you're looking at it in the that's ugly. Well, face it, if I was to simplify this, I have, let's simplify this in a different color. T equals A minus 1,000 over 50. Which really means this, T equals A over 50 minus 1,000 over 50. That's what it means. So if I was to simplify this, T equals A over 50. What's 1,000 divided by 50? It's 20, isn't it? So you eventually get the same form. I just find this form here in the red to be much, much easier to deal with. And the more you solve an equation for a specified variable, the more you'll know, should I distribute, should I not distribute? I'm looking at this going to this very first problem, knowing that if I multiply through, it's going to be a lot easier because I'm going to get rid of any decimals. If I divide it in the first part like I did in the blue, I have these decimals I have to contend with, which are really ugly. And the more you solve them, the more you'll get better at them, and you can start them and decide halfway through you don't like it. Start it again a different way.